Welcome back. Today we're solving equations and inequalities by graphing. For the first example, we have this equation negative 3x plus 20 equals 5. And what we want to do is really split it into two different equations. So this part, the left part, will be one equation, y equals negative 3x plus 20. And then the second half, that's 5, we'll make that y equals 5 so that we have two separate equations that we're graphing. So looking at the blue equation, negative 3 is the slope and the y-intercept is 20. So we know that we're going to start with 0, 20 and then go down and over so that the slope is 3. We know that this y equals 5 is going to have a slope of 0 because that's a horizontal line. So what we could do before we start graphing is create a table. So if we have a table here, and I'll make one for the negative 3x plus 20, you could plug in a couple points. So say you want to plug in 0, that's going to be 20, and plug in 1, that's going to be 17. You can see that's going 3 down each time that we increase the x by 1. So this is 14. That's going to be 11, right? And then I'll just put one more. So that'll be 8. Okay? So we can graph those points. For the second one, I'll make a table just to confirm that this is indeed a horizontal line. So any value for x that we plug in, the y is always going to equal 5. So 0, 5, 1, 5, 2, 5, 105. That equation will always have a y value of 5. So looking at the graph, we can see that the line in blue is our negative 3x plus 20. We start with 20 up here, go down over go down over 3, and we'll continue that until we get to this point. Okay, so we graph those two points, connect them with a line, and then we have the horizontal line, y equals 5, right here. So with the graph, we can see that these 2 points intersect at the point 5, and we could say that's 5, 5, but it's really when this x equals 5. Okay, so we could graph that. We could solve that by graphing. Okay, and then we just make sure we find that intersection. For the next one, we have two graphs. The first we have here is going to be the absolute value. So this will be y equals the absolute value of x minus 4. You know that's going to be a V shape. And this minus 4 means it's going to go to the right 4. And I'll make a table in just a minute. And then the second one, we'll use the second half to make a different equation. Y equals 1/2 x plus 1. So we know the slope is 1/2 and the y-intercept is 1. Okay, so for each of these, I'm going to make them into a little table so that we could see. So here we have the absolute value, and I'll just plug in -1, 0. Oh, I'll continue here so you can kind of see 1, 2, 3, 4, and 5. Okay, so when we plug in -1, we get -5. Absolute value is just 5. Plug in 0, we get absolute value of -4, which is 4. We'll get 3. When we plug in 1, we'll get 2. When we plug in 2, we'll get 0. When we plug in 0, oh, I skipped 3, that's why. And then you plug in 5 and you get 1. Okay, so I skipped 3, so I was wondering where those values are. So you can kind of see in this blue that 4 zeros right here. And you can see the absolute value. You can see that V shape shifted to the right. For the line, well, you can see that it has a y-intercept of 1, because this is going up by 2's here. So this is 1, and then it's going to go up 1 over 2. And just to confirm, it's helpful to make a little, to find some points. I'm going to find some points that that are divisible by 2. Makes it a little bit easier for us. So I'll put -2, 0, 2, 4. So when I plug in -2, I'll get -1, which is 0. And you can kind of see that's right here. When I plug in 0, we get 1. When we plug in 2, I get 2. When I plug in 4, I get 3. And you can kind of see these points right here, and here's 2, 2. So when we have those two functions on the graph, we have the absolute value and the line, you can see that they both intersect at the point 2, 2. So that's when x equals 2. So I'll put the coordinate is 2, 2, but when we solve it, we say x equals 2. But then if you look over here, and I didn't continue the points, you can see that there's another point right here where that line touches the absolute value. And that point is 10, 6. So we have two answers here. We have 2, x can equal 2, and we have x can equal 10. Okay, solving by graphing, looking at the pictures and finding where they intersect. Okay, let's look at an absolute value or an inequality. So here we have x squared minus 4 is greater than 0. So this question is asking, when is this parabola y equals x squared minus 4, when is this going to be greater than the line y equals 0? So if I graph the parabola, we know that it's getting shifted or translating down 4. And so you can see this parabola initially was probably up here as the parent function, and then it moved down 4. And then I'm going to graph, or just highlight, because we already have it graphed, the line y equals 0. Y equals 0 is the equation of the x-axis. So kind of like when you're talking about, when we had a scuba diver the last time, or when you're talking about things that are underwater, down here, below the x-axis, that's the negative, right? So this area is when the y value, so when the x squared minus 4 is less than 0, because it's underwater, right? But we're looking for when is this equation greater than 0. So we're asking, when is this function, in words, when is this function positive? Remember when we were looking at positive intervals? We're looking at when is that y value positive or above the x-axis. And we can kind of see right here. It's right here on this side, right? Anything that's left of the -2, and then also on the right side, anything that is greater than 2. So this is going to have two answers, and I'm going to use that interval notation. So it's -infinity to -2 and 2 to infinity. So I use the union to include both intervals when this function is greater than 0. Okay, let's consider this word problem. A motorcycle is 40 miles ahead of a car. The motorcycle travels at an average rate of 40 miles per hour, and the car travels at a rate 60 miles per hour. When will the car be ahead of a motorcycle? So for this one, we're actually going to use the equations distance equals rate times time. So I'll put distance equals rate times the time. I'll put times with an X. So we're used to seeing the rate as speed. So we have two different things going on. We have the motorcyclist, and then we have the car. So when we look at this one, you can see that the motorcyclist is 40 miles ahead. So that motorcycle is going to start 40 miles ahead. So 40 is the y-intercept, or the start. And then it's going to be traveling at a rate of 40 miles per hour. So let me just put the motorcycle here, and I'm going to write an expression for the motorcycle. The motorcycle is going 40 miles per hour, and I could put t or x. I'll put t just so we could have same variable. Okay, and then plus 40, because that's where it started. It started 40 miles ahead. Now let's look at the car. So the car is behind, so it doesn't have a starting point. It just has a rate. The car is going at a rate of 60 miles per hour. So I'll put 60 times t. So we're looking at this and saying, when is the distance for the car going to be greater than the distance for the motorcycle? Okay, so we're going to have to graph that and see when this blue line, when the car line will be above the motorcycle. So when we graph it, you can see that they're going to, the motorcycle's right here in the orange. It starts at 40. It goes up and over, so that's 40 miles per hour. And we can make a table for that, right? And then for the car, it's going to start at 0, 0, and then it's going to increase by 20. So at 1 hour, it'll be at 60. At 2 hours, it'll be at 120. 3 hours, it'll be at 180. So this is 60 here, and right here is 120. That's 120. So that means after 2 hours, they're going to intersect. So we know that the time when they intersect is 2. But we're saying, when is the car going to be ahead? Well, that's going to be after 2 hours, because at 2 hours, they're going to be at the same distance. So when we look at this, we're just looking at, when is this function above the orange? And the solution, well, it can't include 2, so we'll just have a parenthesis there. And then any other time after 2, because the car is going too fast, the motorcycle will never catch up. So for that inequality, it's not just going to have one answer, but anything after 2 hours. So 2 hours and 1 minute, 4 hours, 10 hours, no matter how long it's driving, the car will be going further and will be ahead of the motorcycle. Now let's continue on to example 3. So we're used to making tables for the graphs. And when we have graphs that are a little bit more complicated, we're actually going to have to make a table. So it's not as, these won't be as easy to graph. So if we have the equation x squared minus 4x plus 1, well, we need to make sure we include that as one equation. And then we have x minus 2 as the second part of the equation, and we'll include that on the second part of the table. So for this one, we're going to plug in different values for each of these. So when I plug in 0.5 into this equation, I'll get 0.5 squared minus 4 times 0.5 plus 1. And that's going to be negative, sorry, let me go back to that. It'll be negative 0.75. And then when I plug in 0.6 into that equation, I'll get negative 1.04. And 0.7, I'll get negative 1.31. And 0.8, I'll get negative 1.56. And negative 1, at 0.9, I'll get negative 1.79. And when I plug in 1, I'll get 1 minus 4 plus 1, so that's going to be negative 2. So when I graph that, it's going to be almost like it's definitely a parabola, but we have 2, 4, right here, 1, negative 2, so it's going to be, and then very close to here, so I'm just going to draw a little parabola here. And it's going to have that U shape, right? All right, now let's graph the line. Okay, so a line, it's not going to be too bad, right? So we're used to seeing this is going to be negative 2 is the y-intercept. And then it's going to be up 1 over 1. So when I'm just going to plot some points here. Okay, so I can see right away that this point right here is going to be is going to be in between 0 and 1. And it's pretty close, it's actually a little closer, so that's why I'm plugging in points that are 0.5 and 1. So let's continue with this table and see which values end up being very close. So when I plug in 0.5, 0.5 minus 2 is negative 1.5. Plug in 0.6, you get negative 1.4. And plug in 0.7, negative 1.3, negative 1.2, negative 1.1, and negative 1. So what we want to do is figure out which value is the closest. So when we look at the two y values, which one's the closest? And you can actually see right here that it is the closest when x equals 0.7. So with the graph and the table, we're able to say x is about 0.7. They're a little bit off. One's negative 1.31, the other one's negative 1.3, but they're very, very close. Now let's go to using some of their graphing capabilities. So you can use a graphing calculator for this one, or you can use Desmos. And for this one, I'm going to again separate this into two equations. So we know that the first one, well, that's going to be a parabola, right? Because x squared, it's a squared function. We know it's going to be going down like this. And then the second one, y equals absolute value of x minus 4. Well, you know that's going to be an absolute value shifted to the right 4. But we don't know exactly where they're going to intersect without looking at the graph. So let me go to Desmos. Okay, and so in this one you can see I graphed the parabola, x squared plus negative x squared plus 8x minus 13. It's right here in the red. and then I graph the absolute value. And what you can see is that these two graphs intersect. And you can see right here, and when I select them, it's going to be 5.303 and 2.697. So when I graph them, I can see right away what the points are. And it tells me, it also has the y-intercept, and you can see that you can find those points as well. So let's go back to the table, or to the problem, and I'm going to make a little sketch here. Okay, so let me just erase this so we could kind of see. Well, maybe I'll just use this a little bit. So let's make this a little bit more of a sketch that we saw in the Desmos. So the parabola was going downwards like this, and then the absolute value was, it was pretty much right in between, right? So that was 4 right here. But we wanted to find those points of intersection. So those points of intersection, well, this point, I'm just gonna, that was, I'm gonna put a little bit up here. That was 2.697, 1.303, and then this point was 5.303, 1.303. So our answer is just the x. So it's going to be x equals 2.697 and x equals 5.303. So when we're looking at the graphs, we can actually determine the solutions by finding those points of intersection. So just remember, when you're solving, we're using the x values. When we're looking at a table, we're trying to look at the values that are the closest. So over here, for example, -3 and 4 and 4. That's what we're trying to find to see where they intersect.